this lesson, we'll be using the identity cos A minus B is equal to cos A cos B plus sin A sin B. So, to prove that sin A plus B is equal to sin A cos B plus cos A sin B. So, take a look at this difference between the identity for cos and sin. So with cosine, the sign that is here inside the bracket is different from the sign that is on the external or on the outside. But with sine, the sign that is here between A and B is the same as the sign that is here. So that's the first key thing you must note to differentiate between two identities, the one for cos and the one for sine. So we're going to use the first identity to prove the one for sin A plus B. So just a brief reminder that I've said in one of the lessons that sine theta is equal to cosine of 90 minus theta. And I said the two angles theta and 90 minus theta, when they're added together, they must give you 90. For example, what do I mean? I mean that if we've got sine 30, sine 30 must be equivalent to the cosine of 60, and that will be 90 minus 30. So sine 30 is equal to the cosine of 90 minus 30. So we must know it's a cofunction, and we're going to use the similar procedure to prove the one for sine. So what are we going to do here? So we are given cos A minus B. How can we write sine in terms of cos A minus B? So there is something I'm going to do here. I'm going to take this down. I'm going to look for the cofunction of A minus B. We can take A minus B as theta. What does this mean? This means that sine of theta, we said, is equal to the cosine of 90 minus theta. Okay. So this means that we are looking for what? We are looking for cos A minus B. Here we are looking for sin A plus B. So what are we going to do? We're going to say sine of A plus B is what we are looking for. Is equal to the cosine of 90 minus, and in brackets we say A plus B. So, don't be confused. We said we are taking A plus B as our theta. This means that sine theta is equal to the cosine of 90 minus theta. So it means that sine A plus B is equal to the cosine of 90 minus A plus B. So our A plus B is theta. So we can say that sine theta is equal to cos 90 minus theta. So I hope it makes sense. So this is what we're going to do. We're going to say that sine A plus B is equal to the cosine of 90 minus, then in brackets we have A plus B. So let me take down the slide. So here we're going to say cos 90, then we distribute the negative sign to the brackets. That will be minus A and then minus B, and then equal sign. So what we're going to do here, we are actually going to separate the numbers. 90 minus A will go together and the B will go alone. So we want to form an identity out of this. So remember, this is the same as this and it's the same as this. So don't be confused. So we can say that cos 90 minus A minus B is equal to sin A plus B, because they are all formed out of the same thing. So for example, if A is equal to C and C is equal to B, therefore we can further conclude that no, A is equal to B. Why? Because they are both equal to C. So in this case, what we are saying here is that we are saying that sin A plus B is equal to cos 90 minus A plus B, and cos 90 minus A plus B is equal to cos 90 minus A with this one, then minus B. So we can say that this one is equal to this one. So I hope it makes sense. So do not be confused. So now we are going to go back to the original business. Okay, so remember on the identity for cos, we said that cos A minus B is equal to cos A cos B plus sin A sin B. So we can take 90 minus A, so we can take 90 minus A as our A here, and then B as our B. So you understand? So this means that we've got cos, this is one thing, we take it as our A, and then our B. So I'm trying to make things simple. So we're going to say cos A. We just copy the identity for cos, and at the end all will be well. So we're going to say the cosine of, because we say we take 90 minus A as our A, so we're going to say cos 90 minus A, then we multiply by the cosine of B, then that is times cos B, and then the sign that is here, because this identity says cos, the sign that is here must be different from the sign that is here. So you are going to say plus, and then we're going to say sine of what? Sine of 90 minus A. 90 minus A multiplied by sin B. Sin B. And there it goes. So remember, we've said that cos the left side, this here, is equal to sin A plus B. So where we see that, we can easily plug sin A plus B. So this is sin A plus B. And then it's equal to, what is cos 90 minus A? That is sin A. And then cos B. Then the sign here is plus. So what is sin 90 minus A? That is cos A. That is the identity, the core function. And then we've got sin B. So check, here is the formula. We have proved it. It says prove that sin A plus B is equal to sin A cos B plus cos A sin B. So the first thing you must do, firstly, before you prove this, is that you must take the original one, find the core function of it, so that you can get sine. We know that cos 90 minus A plus B is the same as cos A minus B. It's one thing, they are core functions and they are equal. So after that, we distribute the minus sign to the numbers or the terms inside the brackets. Then at the end, we've got cos 90 minus A and then minus B. Then you group the 90 minus A together. Then B is left on its own. Then you just copy the procedure that we use when we write the identity for cos 90 cos A minus B. And at the end, we have proved our formula, and there it is. So for further clarification, feel free to ask in the comment section. Thank you for watching.